FutureHouse just dropped 4 insanely smart AI agents. And the craziest part? They're completely free and already outperforming PhDs in some tasks. Backed by ex-Google CEO Eric Schmidt, this isn't a closed beta. It's public, it's powerful, and it might just change how science gets done. So, how do these AI agents work? Let's break them down one by one. Chapter 1. Crow, the speed reader with scholarly muscle. Meet Crow, your first agent, and it's anything but average. Most LLMs today give vague answers to specific questions. Crow? It's a sniper. You ask a technical question, say, what's the most studied gene in relation to insulin resistance? Crow doesn't just guess. It scans thousands of open-access scientific papers, extracts data-rich answers, and gives you the citations on the spot. It's built for scientists, not casual chat. That means zero tolerance for fluff. What sets Crow apart? 1. It parses structured research databases, not general internet text. 2. It ranks sources based on journal impact, citation graphs, and recency. 3. You can actually click through and trace its logic, which papers it pulled, how it scored them, and what lines it used. This is your frontline scout, fast, precise, and brutally efficient. 5. Chapter 2. Falcon, the review-generating powerhouse. Next, we level up to Falcon. Crow gives you sharp answers. Falcon gives you depth. Let's say you want a literature review on gene therapies for muscular dystrophy. Falcon goes beast mode. 1. It ingests hundreds of full-text articles, not just abstracts, plus proprietary databases like OpenTargets and clinicaltrials.gov. 2. It weaves them into long-form summaries covering mechanisms, trial outcomes, failure points, and future directions. 3. Each summary comes with a traceable evidence chain. The output isn't just readable, it's publishable level in some cases. In one demo, Falcon scanned 32 papers, selected 24 as relevant, extracted 62 specific findings, and distilled it all into a coherent answer with clickable sources. This is your academic co-author, minus the drama. Chapter 3. Owl, the experiment detective. Have you ever spent weeks designing an experiment only to realize someone already did it? Owl prevents that. It acts like a scientific detective, specifically looking for past work that might overlap with your idea. For example, planning to run a CRISPR screen on a GWAS gene for autism? Owl will scour preprints, obscure journals, and even clinical trial protocols to check if someone beat you to it. What makes it invaluable? 1. It understands experimental design, not just keywords. 2. It can flag redundant work, saving you months. 3. It highlights missing links in research chains, pinpointing gaps you can fill. Owl ensures your work is novel, not repetitive, a massive time saver and a strategic weapon in competitive academic fields. 10. Chapter 4. Phoenix, the AI chemist that builds molecules. Now for the wild one, Phoenix. While Crow, Falcon, and Owl handle information, Phoenix creates new knowledge in the form of chemical structures. Let's say you found a protein you want to inhibit, but there's no known binder. Phoenix will 1. Analyze protein structure plus interaction networks. 2. Propose 3 to 5 novel compounds that could theoretically bind. 3. Predict synthesis routes, functional groups, bioavailability, and cost. 4. Filter based on patent status and toxicity risks. This isn't theoretical. In one test, Phoenix generated molecules targeting the PCOS-related protein DND1A, then ranked them by feasibility, checking solubility, price, and modification potential for drug delivery. Think of Phoenix as 1. A drug discovery assistant, 2. A molecular inventor, 3. And a cost analyst, all in one. Chapter 6. Real-world use, PCOS case study. FutureHouse didn't just build demos, they ran real tests. Take Michaela Hinks, lead scientist at FutureHouse. She knew little about PCOS, but wanted to explore potential genetic therapies. Here's how she used all 4 agents together. 1. Falcon. pulled a complete literature review on PCOS causes, hormones, diagnostic criteria, and past therapies. 2. Crow identified high-impact GWAS genes like DND1A. 3. Owl checked if DND1A had already been experimentally linked to testosterone increases. It had, but the full mechanism wasn't known. 4. Phoenix proposed 3 novel compounds that might downregulate DND1A's effects, factoring in synthesis feasibility, patent risks, and price. From zero to actionable hypothesis in a single day. This is what they call closing the loop. AI, hypothesis, molecule, lab test, feedback, improved AI. Chapter 6. Why this changes everything. Why does this matter? 3 big reasons. 1. Transparency. Every agent shows its work. You can see what it searched, why it chose certain papers, and how it drew conclusions. No mystery boxes, just auditability. 2. Precision tools. These aren't general chatbots. They use specialized chemistry tools, citation scoring, and even reaction simulators. Because, let's be real, LMs can't even count atoms reliably. 3. Scale plus speed. The average scientist reads a few dozen papers a week. These tools can parse thousands. FutureHouse is aiming to compress years of literature review into minutes. And unlike other AI projects, they run a real wet lab, so their AI doesn't just hypothesize, it gets tested. If they succeed, we're talking about a whole new scientific paradigm, one where you tell the AI what problem you're solving, and it does the rest. FutureHouse's long-term goal? An autonomous AI scientist, one that reads every biology paper, finds contradictions, builds hypotheses, designs experiments, and learns from results. You steer the ship. AI handles the heavy lifting. So, is this the future of science? Let me know what you think in the comments. Hit like if this blew your mind, and subscribe for more deep tech drops like this. Catch you in the next one.